Hello, in this video we're going to prove a claim which says if x is an even integer, then x squared plus 4x plus 1 is odd, and we're going to do this using a proof by contraposition. Now just to review, if we have an original statement of the form if p then q, the contrapositive of that statement, so the contrapositive of something like if p then q, or p implies q, the contrapositive is not q implies not p. And you might recall that these two expressions are equivalent. So the original statement here, p implies q, and the contrapositive, which is not q implies not p, these two statements are equivalent. They are logically equivalent. We could go off and verify that their truth tables are indeed identical. So that's what we're going to use for this claim. We're going to do a proof by contraposition. So we're going to show not q implies not p. Let's begin our proof. When you start a proof, begin with the word proof so that the reader knows your proof is starting, and then lay down your assumptions. So in this case, we'll assume not q. We'll assume x squared plus 4x plus 1 is even. Okay, so let's squeeze out some information from this. This means that x squared plus 4x plus 1 looks like 2k for some integer k. Okay, so far so good. Now, we have to think about how can we show not p? How can we show that x is an odd integer? So we have to do a little bit of tricky footwork here. Let's begin by subtracting a -1 from both sides. Okay, so that'll cancel on the left-hand side, and what we're left with is x squared plus 4x equals 2k minus 1. And by definition of an odd integer, this means that 2k minus 1 is an odd integer. Okay, so we've got an odd equals an odd. X squared plus 4x is an odd integer because 2k minus 1 is always odd no matter what k is. Okay. So on the left-hand side, if we factor out a common factor of x, we have x times x plus 4 equals some odd integer, which we're calling 2k minus 1. Again, this is an odd integer. Well, the only way to get an odd integer over here, the only way this side can be odd, is if both of the factors on this other side are odd. Right? If either one of them were even, then we would be introducing a 2 into the situation, and we'd end up with an even integer on the right-hand side. So that means both these factors on the left are odd, and that gives us exactly our desired conclusion, so we can conclude, therefore, x must be odd. Just a quick note, we have shown in 3 different videos 3 different ways of proving the same claim, and you might compare these methods and observe that probably the direct proof approach was the easiest. And when you encounter other claims in the real world, you have choices in terms of how you prove the claim, and it's up to you to choose which method of proof is the most straightforward or is the easiest approach to prove the claim.